Oh, Van Pickle is not having it today. So, hey everybody, my name is Jo, and I am a developer advocate at Ouijably. I hope you are all having a frightfully fantastic conference so far. As I said, I'm a developer advocate at Ouijably, and we make tech that allows you to build real-time messaging into your websites and apps. And so to mark the spooky season, I'm going to show you how to build your very own online tool to communicate with the spirits, a Ouija board. Now, the spirit board, or Ouija board as you may know the trademark name, is a flat board marked with the letters of the alphabet, the numbers 0 to 9, the words yes, no, and occasionally hello and goodbye, along with various symbols and graphics. It uses something called a planchette, which is a small heart-shaped piece of wood or plastic, as a movable indicator to spell out messages during a seance. And participants place their fingers on the planchette, and it's moved about the board to spell out words. Spiritualists believed that the dead were able to contact the living using such a board as a divining tool. So, how does the spirit board work in theory? It takes advantage of something called the ideomotor phenomenon, which is the process where a thought or mental image can cause you to make an automatic muscular reaction. And these reactions can be minuscule, and sometimes they're even outside of your own awareness. The idea is that by posing questions to the board, participants subconsciously, or maybe even at the behest of the spirits, move a planchette around to spell out the answers to the questions being posed. If the spirit board can make users involuntarily move their hands across a physical board, can we reproduce this effect with computer mice and device gyroscopes? In principle, the effect should work in exactly the same way, with the user's natural desire to push the planchette, replaced by their ability to control the digital recreation of one. So, why don't we build one? Curiosity never got anyone in trouble before. So the first thing I'm going to ask you to do is I invite you to join me as we try and contact the ghost in the machine. Please, if you could follow this link, which Dylan will hopefully paste into the chat for you so you can all join me, or use the QR code that's up on the screen there. And I shall join you momentarily as well. So once you have joined our seance, I ask you to place your hands on your mice or hold your device in both hands and clear your mind of the noise and thoughts of the day. And instead, bring your focus onto the deprecated HTML tag that you miss the most. As we ask, "Oh, apparitions of the pseudo-afterlife, shadows in the DOM, undefined objects of the underworld, what message have you for us today?" I see an M, an N, a Q. It was so close to NPM. No, not NPM. That was a no. G, A, where are we going with this? No. Oh, J. If anybody has a question that they would like to ask the spirit board, please put it into the chat. And if no one has a question for the ghost in the machine today, maybe it's time that we move on and talk about how we actually build this thing. So we need the web app to do a few different things. So you should have seen there that we are measuring the mouse/gyro movements for one or more players. We are going to animate the planchette around the board according to those measurements. We're going to detect when the planchette crosses over a letter, a number, or a word. For the ease of saying those three things constantly throughout that talk, I'm just going to call them characters. And then we need to indicate to the players that a character has been revealed by the planchette. So what is the board composed of? It's a progressive web app, which means that we're going to get that nice save to home screen notification along the bottom if you visit it on a mobile device. We get an offline page, and we get to hide the browser Chrome if somebody has actually downloaded it to their home screen. It's written in TypeScript, and with that and some browser APIs, we're going to write some collision detection. And it needs a messaging service which is going to send data between all of the users to keep the planchette in sync across everyone's screens. Then we're going to need to host the code somewhere. And finally, we're going to add some spooky sounds to add a little bit of accessibility and a little bit of extra spookiness for when a character is revealed. So let's get started and have a look first at the application topology. So the entry point for this app is going to be in index.ts. The HTML is in the index.html file, although honestly, there isn't very much HTML at all. As I mentioned, it's a web app, so we've got a manifest, which is going to set the theme color, set the icons and the orientation for the app, along with hiding the browser Chrome. So we've set it to standalone. We've got an offline page for when there's no network at all. Unfortunately, the app doesn't really work with no network at all, so all we have there is a page that says, please get on the internet. And there's a service worker which is caching all the assets. And then we've got the package JSON and the README. Inside the assets file is our images and our styles. Then we've got the audio files and some JavaScript to add the audio. And then finally, the JavaScript itself, which is actually what is making the app function. So in networking.ts, that's where we'll put the code to connect up all of the browsers using the same board. The planchette.ts file, unsurprisingly, controls the planchette, and the spirit.ts file has all the functionality of the board. So let's start there in spirit.board.ts and actually write some functionality which is going to capture the mouse and the gyroscope movements. So first of all, we create a spirit board class that we're going to instantiate in our index.ts file. And inside it is all the logic that makes the board itself work. So the first thing we're going to do is pass it the ID of the HTML element that the spirit board is contained in. And then we're going to set up a listener for a mouse move event. And we're also going to create a function called enable gyroscope. And what enable gyroscope is going to do is, if a gyroscope is available, it's going to add an event listener that reads at a frequency of 60 times a second. You'll notice here also there's a magic number, so I'm timesing the gyroscope X and Y by 10. That's because gyroscopic movements are a lot smaller than mouse movements. So we're multiplying the value up to make the values raised from the gyroscope and from the mouse a little bit more similar. If you want to build this yourself, feel free to tweak those numbers as you wish. So we want to be able to measure the mouse movements made by every user of the board, not just one user, and then share that data between all of the users. So we're going to create a networking function that uses real-time messaging to send data between the browsers. As you can see here, what we're doing is we're sending a string of nudge. So in our send buffered message function, we have a string which is called nudge, and it is an object which contains the X and the Y values that the mouse or gyro has moved. So next, let's talk about how we actually are going to send that data. And the way real-time communication is often managed between browsers is with WebSockets, something I'm sure a lot of you have already had a go with. It's the protocol which allows real-time communication on the web. And WebSockets allow us to open a connection to send packets of data between different devices. We open a connection, we do a security handshake, and then we're able to send binary data between the computers. The connection stays open, unlike an HTTP request, so communication can actually happen in real time. We don't have to keep polling for changes. But WebSockets, of course, come with a whole bunch of extra decisions in engineering and configuration that we have to do. For example, what happens if a connection is lost? How do we let the user reconnect to get the messages that they missed? Or how do we ensure that the messages arrive in the correct order? Or what happens if we have multiple boards being used at the same time? How do we keep the messages that are being sent separate? And usually, instead of doing all of this extra engineering ourselves, we'd use a library or service to do this for us. And there are a whole load of different options out there. But of course, I work at Ouijably and therefore have the entire of the Ouijably ecosystem at my disposal. So I use their service. And obviously, I think it's pretty great. They're a service built on top of WebSockets, which comes with all of the things that I just mentioned already there for you straight out of the box. And it uses something called a pub/sub pattern to send messages between the machines. And pub/sub stands for publish and subscribe. And it uses an idea of this channel or channels for message exchange. And Ouijably is the broker which relays the messages between the machines on these channels. The data that's sent in the messages is just binary data, so we can send whatever we want. We can create a JSON structure which has a message name and then whatever data we want to send along with it. And by sending and receiving these messages, we can keep every user in sync. And in our case, we'll create a channel per board, and every user of the board will subscribe to that channel. Whenever the user moves their mouse or their gyro, they will publish a message with the delta X and Y coordinates. So if we take it back to absolute basics for a moment, if we wanted to send a message with Ouijably, we do it like this. So first we make a new instance of the Ouijably library and we pass it our API key. And then we create a new channel called movement. We can publish data to that channel. And here we're sending a message, as we did before, called nudge, with data that contains the X and Y mouse movements. And then we can subscribe to that channel to receive messages too. But this can cause a few problems when you're sending data that contains mouse move events or that is triggered by a mouse move event, because there are an awful lot of them, which is going to cause us to burn through our Ouijably messages at a rate of knots. So instead of doing one message per mouse event trigger, we're going to batch them up and send them in a buffer. So that networking function that we looked at before, what it does is it's going to capture all of our interactions with Ouijably and expose a function called send buffered message that we can call. And whenever we send a message using send buffered message, what it actually does is put the message into a variable called outbound buffer. And if during the sending of the message, our buffer reaches the buffer cap, which we've set to 150, it'll flush out the buffer. And flushing the buffer simply takes the collection of messages and sends them all at once via Ouijably in a message with the name bulk. To make sure all of the messages get sent, there's a timer that we set up in the constructor. Every second, the buffer will attempt to flush itself. So if any messages are left unsent in the buffer, they'll be swept up in this flush task. Buffering the messages like this means that we have more control over how the clients send messages, preventing huge spikes in our Ouijably traffic from a user wildly swinging their mouse or their device around. And elsewhere in this class, if a bulk message is received, each of the array elements in the bulk message is looped over, and the message handlers are called for each individual item. So back in index.ts, we're going to register some message handlers to respond to these messages as they get processed by our networking class. So we now have a way to measure mouse movements and gyro movements and to send them between computers. So now let's build the board itself and put a planchette on it. So the spirit board is just a div and its background image is set to the picture of the board on the left. And inside the div is the SVG that is pictured on the right. The SVG is made up of a group of polygons that mask out the area contained by the characters on the board. And it's this SVG that we'll use for collision detection rather than the letters themselves. And the reason for this is because the letters have empty areas that could potentially cause the collision detection to fail. So take, for example, the letter O. If the planchette is centered on the O, that's an empty space and it won't trigger the collision detection, so we need to mask off the entire space. The markup of the SVG looks like this, with multiple polygons, and each polygon has the following attributes. So we have a data item attribute that tells us what character the polygon contains. We have a data focus attribute that represents the coordinates at the center of the polygon. Now, to find out these points, I eyeballed it in Illustrator, I'm afraid. I took the coordinates from Illustrator and added them by hand as an attribute. And there is a mathematical equation to find the center of polygons, but I was already drowning in maths with this project. And since I knew I had a finite number of characters, I chose this option instead. The class is how we're going to select the correct elements to run detection on. So every polygon will have this same holder class. And then the points describe the edges of the polygon. So this way, when we do the collision detection, we have all the information that we need about the character that's been selected right here. And the planchette itself is also a div with the background image. It's absolutely positioned, and I put a transition on it so that when we change its top and left values, it will animate smoothly around the page. You'll also notice that it's relatively sized, so it increases and reduces in size with the window dimensions, as does the board itself. So, in order to move the planchette, first we're going to create a class within planchette.ts, which is going to have render, move, and center methods. So the render method is going to look like this, and all it's going to do is set the translate values of the planchette. Then we have the move function, which is going to update every time we receive those messages on our Ouijably channel. And it'll update the CSS translation on the HTML element, which will then be animated nicely by the transition style in the CSS. And then finally, we have the center method, which is going to move the planchette to the middle of the board when a user initially joins the board. So I don't know if you noticed when you first joined the board, the planchette moved nicely into the center, which is where you always want to start when you're using a Ouija board for a seance. In the spirit board class, we're then going to add methods which call the move and render functions that we just defined. So the render function calls render on the planchette. Then, using the request animation frame API, it queues a callback to itself. And the request animation frame API is a browser API for animating page elements. And what it does is your browser will call this function many times a second to match the frame rate of your browser. And this frame rate normally matches the refresh rate of your computer's display. And this means we're going to be constantly running the render function, which means that our planchette's position is going to update very regularly. So we get that nice smooth animation every time you move your mouse. And then what we need to do is add some handlers into our index.ts file to manage what happens when we receive messages on the Ouijably channels. So if we receive a message called join, then we move the planchette to the center of the board. If we receive a nudge message, which is what we send whenever we move a mouse or the gyro, then we can get the X and Y values and add them as translate values, and the planchette will move. But we don't want the planchette to be able to slide outside the bounds of the board, especially for users with particularly large screens. So let's add in a boundary check to move the planchette back inside the board if it tries to go too far out. Now, this looks like a lot of complicated maths, but all we're doing here is we're measuring the height and the width of the planchette itself, and then the top, right, bottom, and left boundaries of the board. And if the planchette X and Y values goes above halfway the size of the planchette off the board, then we snap it back to the edges. Now, that wasn't the best description, so here's a visual which I hope will help. So I don't want the planchette to be able to move off the top of the board, and I don't want to be able to move further than halfway its own width off either side or halfway its own height off the bottom. So that's what this math here is doing. So the next thing that we want to do, now that we've got our planchette moving around the board and staying inside of the board, is we want to hook up the collision detection whenever the planchette viewfinder moves over the letter. Now the viewfinder is that little circle in the center which we can see through. And here it is revealing the letter S. So the first thing that we want to do is calculate where the center of the planchette viewfinder is, this point right here, which obviously is at 50% of the width and is at 33% of the height of the planchette. So in order to find out where it is on the page, the first thing that we want to do is find out the X and Y coordinates of the top left point of the planchette, then add half of the width and 33% of the height. Then we're going to use the Elements from Point web API to detect elements at that specific location. And this is a super cool API that I only just discovered for this project. And what it does is it returns a collection of elements which are at that point. And we can then put that collection of elements into an array. And once they're in an array, we can do a filter on them to filter for any elements with the holder class. If you remember from a few slides back, that's the class that we put on the SVG polygons. The polygons also have data attributes which contain the character that they surround. So the next thing we want to do is get those attributes to find out which character it is that we're actually going to reveal. Then we want to move the planchette so that the viewfinder sits nicely at the center of the character. That's what this toDetectedItem function inside the reveal method will do. So let's take a look at that one now. The toDetectedItem function is going to read our SVG metadata and return it. So let's have a quick reminder of what that SVG looks like. First, we're getting the data item attribute, which tells us which character it is that we're actually revealing. And then we're getting the focus point, which is the center of the polygon, and splitting it into two coordinates. We then return these two values so that we can do something with them. And back in the spirit board, we're going to add to our render method this call to raise events for newly revealed items. So this is going to do a couple of checks to see whether it's been passed something valid. Then it will stop the movement of the planchette for 3 seconds so that we can do that nice clear selection of an item and stop it from bouncing around between letters. If you've not seen that notation before, that number there on temporarily block movement is 3000 with a separator at the 1000 point, which makes it more readable. We're then going to call focus on to move the center of the planchette viewfinder to the center of the polygon, which we got from that focus point attribute. And the final thing to do is a spooky animation to show the letter that's been revealed. And this is just a div in the HTML with some CSS animation on it. So the div looks like that. It's literally just an empty div. And then what we do in the JavaScript is we set the HTML of that, the inner HTML, to be the letter that we picked from our SVG attribute. Then we add a class of animate and we remove it after 3 seconds. And this is the CSS. So all it does is it increases the scale of the letter, it decreases the opacity, and it performs this nice transform skew, which does that sort of wiggly smoke movement into the screen. And I can only apologize for this CSS formatting. I've put it all on one line so that my CSS can fit in the slide, but I don't advocate writing your CSS all on one line like this. So the next thing we need to do, now that we've revealed the letter, we need to also add the audio which is going to speak the letter. So what I've done is added an audio manager class, which is going to not only play the spooky background music, which you may be able to hear, but it's also going to read out the character that's revealed. And we're going to add some sliders and a config which will allow users to switch the sounds off, because there's nothing worse than playing sounds when people don't want them. The character sounds are all in one OGG file, which was kindly recorded for me by a friend of mine who has a much more professional audio setup than I do. I did attempt to record this myself, and the sound was so cringe that I had to ask somebody else to do it for me. So they're all in one big long file, each letter, number, and word. And we can use something called audio set to split it up, kind of like one might do with a long SVG sprite, where you can detail which point in the sprite you need to use. So what we're going to do is create a class to index each of the samples inside the file. And each one is at a 5-second interval, so we can just play the 5 seconds that corresponds to the correct characters. And so finally, putting it all together, our index.ts file looks like this. When a user joins, we move the planchette to the center of the board. When a user moves their mouse, we receive a nudge message and we move the planchette. If the planchette movement is outside of the board, we snap it back inside the bounds of the board. And when a letter is revealed, we run the animation to show the letter and we play the correct audio. And that's it. Well, that's not quite it. We haven't spoken about the hosting, and the thing that I'm using is Azure Static Web Apps. And there's also a bunch of maths that makes the board responsive. But nobody wants me to do the let me just read you out my JavaScript. There's literally a README on the repo for that, which you can see if you visit this URL here. And it's all open source. So if you would like to build your own Spirit board project, you can do so. I will share out the slides afterwards so you can all get those links. And you may well be asking yourself at this point, what on earth am I supposed to do with all of this? And yes, I will grant that it is a silly demo, but a useful system, I hope, because what we've set up is a method for sending messages between browsers. We could build something like a peer-to-peer multiplayer game with this, or a shared drawing app, now that we can capture the user's mouse movements. Or it could be a shared document editor, or the basis of a chat app, anything that shares data and therefore state between the browsers. And so I hope you find it useful and that you consider building something with it, or just have a good spooky time with the Spirit board tomorrow or on Halloween. Either way, thank you for listening and happy Halloween. And why don't we try asking the board a few more questions? So let's jump back to our slide. I'm going to open the chat and see if anybody has any questions for our Spirit board. Any questions, anybody? Maybe, what's the best JavaScript framework? Dare we ask it that? Okay, if the board is telling me goodbye, I guess it's probably time to hand back over to Dylan. So the final thing I will say is thank you so much for listening. Happy Halloween, and I hope you enjoy the rest of the conference.
That was, wow. I don't even know where to start. That was so cool. Let me find Tony. Oh, Tony's not ready yet, but oh, there he is. He just popped in. Let me bring him into the room.
Yeah, I sped through those slides much faster than expected. Well, I apologize for ruining your perfectly timed schedule.
No, it just means we have to talk for 20 minutes instead of 10.
Oh, wow.
All right. So you reached out to me like a month ago and you're like, so I have this idea for a talk, maybe like a browser-based Ouija board. And I was like, yeah, that sounds great. But like, whoa, that was just so cool. So like, how did you get from like, what was the process from like zero to like deciding to do this? And then like, what was it like iterating on this? And how did you Share your creative process, because that was just way too cool.
Well, I have to admit, the actual idea came to me. Somebody that I follow who does nail art on Twitter did beautiful planchette nails a month or so ago, and I was like, oh, I could make a spirit board online. Because obviously working at Ouijably, I'm always looking for real-time apps to build. And I'd literally just finished building this peer-to-peer. It's not so much a framework as a code base that people can use to build multiplayer games themselves. So I'd just built a multiplayer card game, sort of board game, card game. And so I had this sort of peer-to-peer messaging base set up ready. And I thought, well, it's not too far of a transition to
nice.
take it to a spirit board.
It's a board game of sorts, just without control.
The spirit board was originally released as a board game, and then the spiritualists picked it up and were like, we can contact the dead with this.
It's pretty amazing. Unintended consequences, right?
Right. But the other thing that I've been working on recently is a whiteboard, a shareable whiteboard, because I mean, it's one of the things that we've all been, the two things that we're all using a lot at the moment is, you know, sharing video chat and sharing editing of things. And obviously you need real-time messaging for that a lot. So capturing the user's mouse movement was already something that I was looking at. And so again, it wasn't too far a step to go from sharing that mouse movement across browsers to sharing it for a planchette.
That is so cool. And I loved you got to read a couple of those lines again, because they were so amazing. Like, summon your like doms, spirits. I don't remember what you said, but I want to hear a few of those again, because those are just too funny.
What was it? It was apparitions of the pseudo afterlife.
Yes. That was amazing.
Shadows of the dom, and I can't even remember what it was anymore.
It was like the JavaScript spirits just went through you and brought all this out. That's great.
They did.
I think we should just adopt those as the normal terminology for these.
Undefined objects of the underworld.
Yes, that's great. So how, anyone's like, well, how much time did it take you to like create this? Because I mean, luckily you had already done a lot of work on sort of the underlying framework, but like, obviously it took a lot of time to design it and make the clips and you make your house look like you're, at a seance and all this stuff, right? So like, what does it take to do something like this in terms of time for you?
So the concept itself was actually not the difficult part. The most difficult part is the bit that I didn't really touch upon, because honestly, it was horrible and it would bore everyone to death to hear quite how much pain it caused. But the responsiveness of the board and the planchette.
Oh, yeah.
Because we're doing X and Y coordinate calculations, and they are then based on a responsive design, but that responsive design has to stop. So I didn't want it to get too large for those of us who have a very nice 39 by 39 widescreen monitors. I didn't want it to get super huge. So it stops at 1,200 pixels wide and 768 pixels high. So it won't get any larger than that. But it just made the maths calculation. First of all, you're calculating the percentage across the board that you've moved, but also the planchette also changes size. So you then have to recalculate the size of the planchette at what point that viewfinder is at. And that was the thing that took the time. I mean,
it's like SVG has not evolved since 2001. I mean, the browser implementations have gotten good, but SVG 2 has been like the spec that's never been finished. And there's proposals and false starts and all sorts of things, but we still like don't have a lot of the primitives you would want to be able to like constrain this thing to this other thing. And like D3 picked up a lot of the slack, but that's if you want to use D3 in those particular ways, not if you want to like do something that's never been done before. And the math is truly hideous because it's like coordinate systems inside of coordinate systems, constrained with things that don't want to be constrained. And
I mean, don't get me wrong, I absolutely adore SVG, and
I do. I want version 2. Yeah.
I mean, the view box.
Yeah.
Once you set that, it scales naturally with the window size. So the reason why I use SVG for those outlines, I mean, apart from the fact that we get that nice polygon, is that the SVG isn't actually the part that needed the extra maths. It was the movement calculation that needed the extra maths.
Right. Interesting. Yeah. The
Plus, because I have Illustrator, it's very easy for me to just go in and, edit points on an SVG and things like my eyeballing the center of each polygon instead of doing the maths to work out where it was.
The only way I know how to draw is in code. So I cannot use a tool like Illustrator. It looks terrible. So like when like the ability to write a circle with markup came out, I was like, oh, finally I'm saved. I can draw a perfect circle.
I think one of the unintended consequences of your talk is that it's very cat friendly. My cat sat in front of the television all of the time watching the Franchetti go around. Was that accident, or was that something you tested with your own cat?
You know what? I didn't think of that, but now that you said that, I want to make a multiplayer cat fascinator. Maybe a multiplayer multi-cat fascinator.
That is awesome. People have asked if the cat vampire is going to make a second appearance. I don't know if she's up for it or he is up for it. Yeah. She's
not around. I'm afraid she was sat on my lap the whole time I was getting prepared for this, and then she was like, "No, I've had enough now." So you have to deal with her just in pumpkin form.
Yep.
The reason for the cape is that she's currently got a cone on her head because she had a vet's visit a few weeks ago, and I was looking at the cone and I thought that looks quite a lot like the collar of a Halloweeny cape. So, the cape was born.
I always call those the cone of shame for the pets. Like, the pet's been not bad, but like they feel like they've been bad and they kind of mope around. So anything to like make it more fun is good.
She's very unhappy with me and her cone.
It's for the best. It's for the best.
Yes. Let's see.
You built this on top of Ouijably real-time, obviously, and I'm sure that made it super simple for this to work. But is this something that would work with other platforms, or would you recommend Ouijably as the platform that people would use if they're building something similar?
I mean, you could use vanilla WebSockets without using a service, but as I mentioned, you suddenly have all these different things that you have to start thinking about. So things like reliability, things like message ordering, creating different WebSocket connections with different. The lovely thing about this is I can give each board an ID and I create a different channel for each board. So this one is our special HalfStack spirit board, but you could create one for your friends that's separate. I could have 3 different boards running at once, and Ouijably would just manage all of that for me. So you could indeed do it other ways, but I figure this is the easiest.
Yeah, the tools are there to make it easy, right? Use the tools.
Yeah.
I like it.
I am really curious to see what your visual recap is going to look like, because there's so many interesting things to inspire our artists today.
Yeah, honestly, any excuse to be a bit of a goth is it's my cup of tea. You got me hooked.
So what you're saying is we need to do a Halloween HalfStack every year to like have an outlet for this stuff.
Absolutely. Yeah.
Nice. We still have a few minutes, so it's all good. So I guess I'm like, you are one of, there are several like really amazing creative speakers that have spoken at HalfStack over the years, but like you are like in this group of people who just everything they create is like like really beautiful and amazing, and like
Aw.
and just really well put together in terms of like thinking through all the details. So like, were you always like this? Was this a relatively, have you been doing, like, how long have you been giving talks that are like this, like visually creative, where you like bring all these things together? Or is it a relatively new thing in your life?
I've I've always had stupid ideas, and building silly things on the web has been my favorite thing for years. But I feel like only recently I've had the confidence and enough gathered knowledge to actually build the things. You know, I did have like Biscuit Tinder I came up with ages ago. I like to build things that are based on puns. And so I had this idea for Biscuit Tinder where you can rate your favorite biscuits, and we could like collect the universal best biscuit from everybody. And I didn't know how to build a back end for it. So I made the front end for it. I did all the nice animations, and then I left it and it died.
Now, if it had been like cream or jam with scones or scones, Tony would have helped you finish it, I'm sure.
Yeah, I also would have fixed it so it's always jam first. That's the
Yeah.
only true way. So what would
It's
be
just
our
not
favourite-
right. It's just not right.
It is. Let's not descend into this. I already get enough flack about myself. I'm more intrigued to know what would the winning biscuit have been, in our opinions.
Well, exactly.
I mean, I'd have gone for rich tea. 'Cause
Really? The most boring of all the biscuits?
no, that's what you do with it. I put jam and cream on it.
Oh, well. I mean, that's cheating.
So for our American audience, biscuits are generally known as cookies, right? They're like a type of cookie, yeah? Mm-hmm.
Yes, sorry.
Well, I mean, the beautiful thing about the British version of English, rather than the English that Americans invented, English, I'm just kidding, obviously. Our language just like filters like 10 different dessert types just down to cookie. You know, so we don't have like all the different types that you have. And similarly, like for chips and stuff, you know, you've got like 10 different words, and we just call them all chips because we're lazy. So it's one of the best things about being in the UK is like getting the distinction of each type of thing. So what is the strict definition of a biscuit, and what would qualify as a biscuit worthy of entering your app?
I mean, there's a whole like tax law about this, isn't there? Like this biscuit starts crunchy and goes softer as it gets older, whereas a cake starts soft and goes harder as it gets older. So I can't even remember. There's something about Jaffa cakes and being taxed and something ridiculous.
Yeah, I feel like if I watched every year of like the Great British Bake Off or baking shows they called over here, I might know by the end of that. But you know, we don't have all the things. That's cool.
Yeah, I love that the Americans can't deal with Bake Off as a term, and it's the baking show.
It's all about SEO. It's SEO. Like people here search for baking shows, they wouldn't know to call it a bake off. Yeah.
Back in the LiveJournal days, I used to be part of a LiveJournal community called the Pie Off, and we used to have yearly pie baking competitions, and everyone would bake a pie and bring the pie and vote on the best pie.
Nice. Pie is always one of those things that you feel like it should be easy to make, and it's really not. At least not to get the. I mean, you can make a really ugly looking, good tasting pie, but make a pie that looks nice and tastes good is kind of the challenge.
It's another weirdness in the States. You don't have savory pies.
Yeah, what do we call them? Well, like we have like chicken pot pie, I guess. Like in an Irish restaurant, you know, we might have shepherd's pie, but pretty much it's a pretty niche. It's not like something you would get at any restaurant or any train station or whatever, like you would in the UK.
I'm going to say something controversial as well and say that those aren't true pies. Those are faux pies.
I know.
Pizza pie is not a pie either.
No.
Yeah, it's more deep dish pizza is more like a quiche of some sort with Italian quiche or something, right?
Oh, it's dinner time here in the UK. I'm getting very hungry.
Yeah. I keep waiting for the house like at our event in Phoenix. We have it at the Alamo Drafthouse Cinema, And there you sit in the theater and you just fill out a slip of paper with whatever food you want. And the house elves just bring it all day long. So I'm kind of like wondering where my house elves are for this event.
Yeah, my house elf has wandered off and left her costume here. In fact, I can wear it myself.
Nice, nice. We have about 3 more minutes. Let's see what is, I think you mentioned, if I remember correctly, like, do you have, like, what's your approach to JavaScript? Do you like have a framework of choice, or are you more of a vanilla JS kind of person, or what do you?
Oh, I'm very, very vanilla.
Yeah.
Yeah, having done browser advocacy, I'm all about vanilla and using as many web APIs as you possibly can. I've worked in jobs where I've used React, and I don't have anything against React. I think it's great for the things that it's great for. I've recently been exploring using Vue in a few projects, and I've actually really enjoyed that. The multiplayer game that I spoke about earlier uses Vue, and that's really cool because you have different phases of the game. You can make a different Vue component for each phase of the game, and then use your Vue logic to just choose which component to show, and it's really nice and simple. It's all in HTML, no JSX, and that's kind of all right by me.
I wonder if like ECMAScript 4 had been standardized, right, we would have had E4X, which is a lot like JSX, So part of me feels like maybe we should introduce something like JSX as part of the browser ecosystem, because we did try at one point and we just we punted on it, or we stopped. I don't know. It was just a stray thought. What do you think about that? Not that I'm advocating for or against it. Just curious. Yeah.
You're talking to someone who's a giant fan of HTML. Like, yeah, I freaking love HTML, and we keep ruining the web by not using HTML as much as we should. And yeah, let's go back to boring old HTML as much as we can. Let's make the web as accessible as it should be and as small as it should be. And yeah, that's my.
So yeah, I agree. I mean, it's always a challenge. I always felt like the point of JavaScript frameworks is to fill in the gaps rather than to be this permanent thing that you need on top of the web. At least that was the goal of like Dojo 0.1 back in like 2004. It was like, let's just fill in these gaps for a few years so that we can like wait till browsers get better and standards get better. But it always feels like we want more than we can keep pace with. So it's kind of this, but there are waves of like where we back off and we kind of standardize things, and then we kind of race ahead again and then kind of come back. So it's kind of it's an interesting cycle of ebb and flow. So
I think we have to
are in that flow now.
Yep.
Sorry, Jeff.
Yep. Awesome. Well, thanks for making the time, and thanks for the amazing talk, and we'll talk to you soon. Thanks. Bye.
Bye.